Elon Musk recently unveiled the new 9,000-ton IDRA Giga casting machine, which will revolutionize everything. Elon Musk is well known for being the visionary CEO of SpaceX and Tesla. Did you know that he is also developing a project that has the potential to dramatically alter manufacturing? It is known as the Hydra. There is nothing like this enormous machine in the world, and it could alter how we construct everything from cars to buildings. The Hydra, the giant casting machine. How gigantic is this monstrous machine? And does it live up to its name? How does it function? Gigapress, Tesla's motor's secret weapon. Tesla has made significant investments in its Gigafactory and will continue to do so. But do these enormous machines offer a competitive advantage? And if so, how much? Check out this video to learn more about Hydra's operation and potential implications for manufacturing in the future. The largest die casting machine is in use right now is the Gigapress, and it shouldn't come as a surprise to find Gigapresses in Tesla plants, given the company's penchant for undertaking ambitious projects. They are manufactured by the Italian manufacturing business Hydra, and from what we've heard, Tesla has been a long-time customer. They have dimensions of 20 meters by 7.5 meters by 6 meters. The Gigapress, with a 61 kiloton clamping force capacity, is the most potent die casting machine ever produced. They weigh more than 400 tons, and just one needs to be transported by more than 20 flatbed trucks. Additionally, these massive home-sized die casting machines have the ability to produce very large components. Currently, only Hydra and LK Group are making these gadgets, and furthermore, Tesla was the first company to order a Gigapress. Since that time, a lot of people who work in the die casting industry have been anticipating seeing the largest die casting machine in the world in action. Riccardo Ferrario, general manager of the Hydra Group, first proposed the Monica Gigapress in the later part of 2018. Tesla submitted construction work permit applications around the end of July 2020 in order to get ready for Fremont's die casting machine 2. As of September 2020, the second Gigapress at Fremont had been installed, and the first Gigapress at Fremont had begun producing trial runs of the Model Y single-piece rear casting. It wasn't until the end of 2020 that Tesla started using a modified OL 6100 CS Gigapress for production. According to Jerome Gillian, the business is creating a massive, enormous machine to build full-size cars in the same way that tiny cars are built in 2019. The Gigapress is more of a die casting system than a tool. It is equipped with all the devices and the systems required for die casting. 2 sets of ovens in the Tesla Gigapress handle the aluminum alloy that makes up its parts. One is a natural gas-fired melting oven with an operating temperature of 850 degrees Celsius. Another oven is used to contain liquid metal that has been electronically heated to a temperature of 750 to 850 degrees Celsius. The Gigapress serves as the brain or the die casting mechanism for the entire system, and with the exception of its enormous size, it is constructed and operates similarly to the typical high-pressure die casting equipment. The following steps can be used to break down the Gigapress operation. Prior to casting, the aluminum ingots and cutoffs must be melted to 850 degrees Celsius in an oven. Tesla constructs the chassis of its vehicles as a single unit using the Gigapress. This means that instead of dealing with 100 additional parts if it had been practiced bolting and welding things together, the automaker only deals with a maximum of 3 pieces, similar to how the auto business has historically operated. Tesla may have considered the advantages before committing to Gigapresses because they need a significant financial commitment and installation area. Undoubtedly, Gigapress is a game changer for the car sector. The only places where the Gigafactory is currently built or is anticipated to be built are the Vermont-based Tesla factory and the 3 Gigafactories in Shanghai, Berlin, and Texas. The first 2 Gigapresses were delivered to Tesla's factory for installation. In the initial preparations for assembling the first aluminum die casting machine, known as the DCM-1, started in May.
My name is Anna Ferris.
I'm Quinn92.
Josh DeMel.
Of 2020. Tesla had various licenses from the city of Vermont to build the DCM-1 housing facilities that were necessary. The DCM-1 facilities development was largely complete by August of 2020. And in September of 2020, Tesla started testing its use of the first Gigapress to cast the Model Y's rear chassis in a single piece. By that time, the DCM2 facility had also been completed. The Gigapresses were still in use at the Vermont factory. On May 11, 2020, one of the Gigapresses caught fire while being used, posing an issue. According to the fire department, molten metal and hydraulic fluid caused the fire. No one would be harmed, although it wasn't a serious matter. Megacasting may involve various concerns and should be taken into account, but as technology develops, it will also find solutions to these issues. Tesla added 3 more Gigapresses to its Gigafactory 3 facility in Shanghai. Preparatory work started towards the end of 2019 and was finished by October of 2020. At Giga Shanghai, LK Machinery developed the Gigapresses. The name Impress Plus DCC 6000 was given to it, and in July of 2020, Tesla started construction on the Giga Berlin, which will house 8 6,000-ton Gigapresses. Let's look at a few Megapress advantages. The Gigapress will considerably improve the manufacturing efficiency of large and complex objects. The Gigapress will enable manufacturers to cast a single massive component as opposed to numerous smaller ones. The accompanying assembly tasks will essentially disappear as a result. And there is a significant labor and time savings as a result, which will also lower production costs. By casting it in a larger single piece, the manufacturer will be able to produce a lightweight framework and increase the casting strength. By casting a single opponent, the risk of alignment issues with the parts during assembly would also be removed. Consequently, it would simplify quality control and allow manufacturers to create costs of the highest caliber. Additionally, the body shop size will be considerably reduced, which will result in less land being used for robot manufacture. Currently, it appears that the Gigapress is mostly used to produce castings for automobiles. Automobiles have a complex structure and are made of several little parts. Reducing the number of castings to a few would result in a considerable improvement in manufacturing efficiency. The rear body structure of the Model Y is being cast by Tesla using the Gigapress, and it will create a single item from 70 casting components. The Gigapress will also be used to cast the front chassis parts. Undoubtedly, this has altered how we will view the current production processes. Before we start seeing more applications for this technology, it may take some time since it is still a relatively new technology. We anticipate seeing the Gigapress used in many more creative ways across numerous industries. Megacasting is certainly an intriguing idea, but many still have concerns about the technique's viability. Since this is a new technology, there is still a ton of research to be done on the effectiveness, expense, stability, and the reliability of the Gigapress. When it comes to embracing a new idea, the industry has always been skeptical. The trend towards massive casting may therefore take some time for other manufacturers to adopt. The information we've got so far from Tesla is limited. Tesla has manufactured the Model Y rear chassis successfully in test runs. And although it cannot be disputed that they underwent numerous adjustments to arrive there, the design process for the megacasting could get easier as manufacturers gain a greater understanding of the technique. We must use extra caution while working with that much metal at once. Cadillac, BMW, and Audi have all used their castings in their vehicles. Thus, Tesla isn't the first automaker to do so. However, nobody has tried to do it on the scale that Tesla is. It remains to be seen how the rest of the industry will attempt to catch up. Tesla could be able to maintain its competitive edge for a while. Even JP Morgan believes that because they are flexible enough to adjust to the changes. Only new entrepreneurs will have a chance to replicate Tesla's success in this area. The sole other business now using Gigapress is headquartered in South Korea and doesn't even produce automobiles. As a result of Tesla's success, other automakers are reportedly considering purchasing their own Gigapresses. To overtake Tesla, they still have a long way to go. Elon Musk claims that the DCM2 will be used to construct the Cybertruck's body. The new 9,000-ton Gigapress has arrived in Giga, Texas after undergoing rigorous testing at Idra's facility in Italy. Why Tesla is transporting a huge 9,000-ton Gigapress to its Asian facility? Tesla experts are now working to install the device in preparation for the commencement of Cybertruck production. Tesla is currently expanding the company's capacity for production significantly. The EV manufacturer intends to build 20 million vehicles annually by 2030. Tesla must first streamline its manufacturing process in order to meet its 2030 target. All things considered, it appears that Elon Musk and Idra have just fulfilled their pledge to revolutionize the automobile industry. With the Gigapress now running, we may soon anticipate the mass manufacture of more reasonably priced electric vehicles, and everyone will be happy about that, perhaps with the exception of the oil companies. What do you think Tesla's chances are achieving its target of producing 20 million vehicles annually by 2030? Comment below.